Today we're going to talk about special right triangles. And to get into the special right triangles, we're first going to look at a few Pythagorean theorem problems. These problems will help us to see a pattern emerge, and the pattern is what we're going to use for our special right triangles. For this first one, they have given us, all three of these actually, are what we call 45, 45, 90 triangles. It's an isosceles right triangle where the two angles are, the two base angles are congruent and they end up being 45. And so we're going to use that term 45, 45, 90 for one of our special right triangles. And so knowing it's isosceles, these would both be equal, being both 6, and then they had the hypotenuse 6 root 2. If we were wanting to look at that in Pythagorean theorem, we would be looking at solving 6 squared plus b squared equals 6 root 2 squared. And when you're squaring a radical like this 6 root 2, you want to think of it as, write it twice. That's the easiest way to understand what's happening here. And 6 times 6 is 36, and root 2 times root 2 is the square root of 4. And so you multiply the numbers up front, and you multiply the roots. And then you want to work with them together. So the square root of 4 is actually 2. And so we're going to have 36 times 2, which is 72. And so on the left side, we'll have 36 plus b squared equals to 72. Subtracting 36 to get the b squared alone, you get 36, and then when you square root, you get 6. So b is 6. That way we can work it with Pythagorean theorem to get there. So we have a as 6, b as 6, and c as 6 root 2. Looking at the next one, we have 7 and 7. So you have 7 squared and 7 squared, and you're going to get c squared there. And so this is going to give you 7 root 2 once you're done. I'm just going to skip to that one to save time. So 7 root 2. So you have 7, 7, and 7 root 2. This one's a little bit weird. They only gave you the hypotenuse, but these are, it's an isosceles triangle, so these are actually equal, so I'm going to call them x and x. And so we're going to be solving for x here, and we've got x squared plus x squared equals 3 root 2 squared. And so squaring that 3 root 2, again, think of it times itself. And so the 3's multiply to give you 9, and the root 2's give you root 4, which is 2, and that's really 9 times 2, so that's 18. Over here you have x squared and x squared, which means you have 2 x squareds. In the next step, we will need to divide by 2 because you have to isolate the x squared before you square root. Divided by 2 gives you 9 over here, and then when you square root, you get 3. So we have sides of 3 and 3. So a is 3, and b is 3, and c is 3 root 2. So what we want you to see is this pattern, how we have the same number and then the same number with root 2 on it. So you can see the two legs are the same, and then they have that leg number with a root 2 times it. So the pattern that we should see here is that root 2 times the leg is going to equal the hypotenuse. And if they had given you the hypotenuse and you wanted to solve for the leg, it would be the hypotenuse divided by root 2 to find the leg. And really, those are what you can use to solve for the legs and hypotenuses in 45, 45, 90 triangles. Let's look at a couple example problems. Here we have a 45, 45, 90 triangle, and they have a 6 labeled as the side that they're giving us. How I work these is I look at what it is across from. The 6 is across from the 45. So I use the rule, and there's other ways to work this. I know about 3 different ways, but I like to use patterns. I find they're the easiest. So I always write down the rule. So I've got my 45, 45, 90, and the rule is x, x, x root 2. And if you're writing this down for every single time you're doing the problem, you're going to very easily memorize it. So you start with the number that they gave you in the image and what it's across from, and that's what you put it underneath. And then you use the image and you're filling in to complete the pattern here. So x is 6 because it was across from the 45, and what's across from the 45 is your x for your rule. Notice that the x in the rule and the x in the image do not match. They are unrelated. The x here is just the rule. So we've got 6 for our x in the rule. That means that this one will also be a 6, And so since x is 6, you're just going to put the x right here as 6, and you're going to put the root 2 times it, which is just 6 root 2. So now we have all three sides of the triangle, and you want to take your work here and you want to put it back on the picture. So you've got your two sides that are across from your 45s are both 6's, and the number across from the 90 will be that 6 root 2. And that's the answer we were looking for on that problem. On the next one, they give us a 9 root 2, and it is across from a 45. So again, we're going to write the rule down, which is x root 2 again. And so the 9 root 2 goes under the 45. So we're going to take that 9 root 2, and we're going to use that as our x. So right here, where the x is at, you're going to put a 9 root 2, which means you have to take that and multiply it by a root 2. And your roots will multiply to simplify to a root 4. And root 4 can simplify to 2. So this is really 9 times 2, which is 18. We're going to put that back on the image. So across from our 45s are the 9 root 2's, and across from the 90 is the 18. And in that case, that's the one we were looking for. For number 3 here, they gave us the number across from the 90. That's our hypotenuse. And so when we plug this into the rule, we have our rule of x root 2, and the 90 is the 9 root 2. And so this means that x root 2 is equal to 9 root 2. And to solve for x here, we're going to divide by root 2. Just like I said on the previous picture, if you have the hypotenuse to get the leg, you're just going to divide by root 2. So the root 2's here cancel, leaving just x, and what's amazing is that you had a root 2, so it is going to divide really nice. Root 2 divided by root 2 just cancels to 1, and so you get 9. So x is 9. So that means in our table that x's will both be 9s, and that means that across from our 45s we're going to have a 9, and across from the other 45 a 9. And that was what we were looking for that problem. Here are a few more. I want to skip ahead to number 5. Number 5 is pretty much like the most common problem we're going to see for these, and that is having a whole number for your hypotenuse. We like these because they are the hardest kind that we could do. So we have 45, 45, 90, and the rule again is x root 2. And so the 90 is the 8. So under the 90, you're going to put the 8. And that means that that is what you're going to start with. And again, that's the hypotenuse. And like we said on the previous page, if they give you the hypotenuse to get the leg, you're just going to divide by root 2. And I like to use the table though, so I'm looking at this and I'm seeing x is equal to, or 8 is equal to x root 2. And I'm going to divide by root 2 to get x alone. And you're not allowed to leave your answer like that. You have to do what's called rationalizing the denominator. You're not allowed to leave a root on the bottom. So to rationalize a denominator, what you're going to do is you're going to multiply by the denominator over itself. I call this multiplying by the ugly one because this is equal to 1, and so technically I am multiplying what I had by something equivalent to 1, so it's not changing the value. And I used a 2 because you want to get the root out of the bottom. And so we know how when we're simplifying a root, it takes a pair to get out. So you have your pair of 2's, that's going to get you out of the root. So the top is 8 times root 2, and the bottom root 2 times root 2, which is root 4, which is going to give us 2 on the bottom because root 4 is 2. And then you simplify if you can. So in this case, I have an 8, and I can simplify this, but if the 8 happened to be an odd number, this is how I would have written the answer, and I would quit here with that as the answer. But for this one, the 8 does divide by 2, so you're able to get 4 root 2. So these are each 4 root 2. And that means in the image, these will be 4 root 2's. Now, I knew this was a 45, 45, 90 because these were both labeled with x's, and that meant it's isosceles, and that meant that these are equal, and that meant that that's a 45, 45, 90.